Okay, I'm going to talk about combinations and permutations. And overall, this is just a straightforward special application of the division rule. And the idea of the division rule is simply that if you have an overcount by the product rule, then you have to divide to remove it. For example, if I have a particular problem, and the idea is we have n objects. If I was only interested in arranging these objects, then we would have n factorial arrangements of them. But if let's say we have a particular problem of this. So we have n objects, we could have n factorial arrangements, but let's say rather we said that I wanted to pick r of them to give place awards. In other words, I'm interested in, first place, and then second, and then third, and then all the way down to fourth place. What happens for all of these, for first place, there's only one person that's chosen. For second place, there's one person that's chosen. But on the other hand, there's a subgroup. Once you do this, we have n minus r people without awards. Well, if you have n minus r people without awards, then how you arrange people who have no award doesn't matter. And given that we're going to have n minus r people without awards, I forgot, eraser options, delete strokes. Those people have n minus r factorial arrangements that would be an overcount of the original n factorial. And so if I would want to simply say, if I pick r to give awards, then to pick r for awards with order, then it's going to be n factorial ways to arrange all n people, but I have to remove out those without order themselves. This becomes a problem that occurs a lot of times, where I would like to choose awards for people. I would like to put first, second, and third place. I would like to pick a president, a vice president, or other selection with order, and that happens all the time. So what we're going to do is we're going to make this particular rule into a function that we use for a lot of different types of problems. And looking at that, if we are going to pick r from n with order, so the definition that we're going to use for this is called r permutations from n objects is going to be p n r, which is going to be n factorial over n minus r factorial. And normally we say that we pick r with order from n. So if you have a problem that involves picking r with order from n, then we're just going to use the r permutation function, which is just the division rule. One thing to notice on this is that we could actually do this, without using factorial notation. We could pick r and count it by simply using the product rule. The idea behind that would be if we would sit there and say, if I want to pick r from n, and how many ways to do this? Well, for first place, there are n people for me to choose from. But then for second place, once I've already used one person, I only have n minus 1 left over, and so that would go for my second place. And then I would have n minus 2 for my third place. So if I pick first place, I have n choices, but once they're up there, I only have n minus 1 to pick out of the second, and then I have n minus and. Finally, I would get n minus r plus 1 for rth place. Since they do the same thing, these are just going to be equal to each other. And so we can actually write PNR in factorial notation. We could write it as just simply a product. But they are the same thing, and they count the same object. And so you ought to be able to at least definitely memorize this first formula, but more importantly, know where it comes from and how we would use that in particular problems. So, for example, if I would say you have 5 people and you want to pick 3 with order, then we're just talking about 5 pick 3, which is simply going to be 5 factorial divided by, we divide by the people that have not been picked, so 2 factorial, because I don't worry about that. And again, you could write this as 5 times 4 times 3 if you want, but personally I would rather have you leave it in factorial notation. So I look at it and I understand that you know how to use the division rule or this particular function. In the end, though, you're also going to have to, if you check the back of the book, you're going to have to be able to do multiplications. If we have another example, let's say we pick 5 to play basketball from 16, and then it'd be just, okay, from the 16 people, we're going to pick 5 to play basketball, or we're picking with order. Why do I know it's with order? I just said pick 5 to play basketball. Well, there's 5 positions. You got guard, shooting forward, power forward, center. Each of those is a very different position, and so this would be 16 factorial ways to arrange everybody, and then divide by 11 factorial. And I would personally rather have you leave it like this. Again, what is this 11 factorial? What this 11 factorial is 16 factorial is ways to arrange all 16. 5 of the people will be out on the court. They matter. But on the other hand, you're going to have 11 people sitting on the bench. How they arrange themselves on the bench does not matter. And so you have to divide away that arrangement due to it being an overcount of arranging all 16. That's the idea behind this function.